All right, just make sure. I'm just gonna make sure the recording is fine. How do I turn this off? April 23rd. Great. Welcome to our last lecture. So today we're going to briefly have a revision, and after that I'm going to talk about the exam structure and a couple of housekeeping things. So I'm dedicated to provide you with feedback for your assignment as soon as possible. So the assignment was due 2 days ago. So we have run a test, and this is the provisional result. So everybody did pretty well. So don't have to worry about your score. And we are applying the final touch on your scores. And if you submit in the normal time, like if you didn't apply for extension, or if you're not an ELS student, then we're working very hard to release your scores by the morning of Saturday. So we're working hard to do, hopefully we can release the marks Saturday morning. And if you submit late, if you got late submission, if you got extension, and if you got if you're an ELP student, then we'll need to release your score later because Saturday is not even their deadline yet. And most likely what happens is that we'll probably release the score, but we couldn't release the solution because some people's deadline has not been passed yet. So, but we want to provide you with the feedback for the assignments so that you know how you did in these each of the assessment. Because next, I think the exam is in 2 weeks. So we would love if you guys have this feedback before the exam as soon as possible. So I can completely understand that. So today we're going to talk about probably something that most people care about in the course is what we'll cover, what we will not cover in the exam. And so this is the syllabus overview. We talked about data modeling and data design in the beginning. So we learned how to do ER, how to draw ER diagram and how to map that into relational data model. And after that, we talked about how we can map that into create table statements so that we can create a schema. And after that, we learned more practical stuff. So this part will be heavily tested in exam, and we will talk about how many questions are devoted to this part. So we expect you to be able to write SQL queries, functions, aggregations and triggers, and we'll test your ability in PostgreSQL as well as Python, and specifically the usage of CyclePG2, the package that allows you to interact with PostgreSQL from Python. And the second part of the course is theory heavy. So the first half of the course is code heavy, and the second half is theory heavy. So we talk about relational algebra. We talked about, well, first we started our discussion with functional dependencies, and we talked about normalization, and we talked about performance tuning. So everything in gray will definitely not be tested. So I know that in the last practice you learn how to use SQLite, but you don't have to worry about SQLite, and you don't have to worry about access control in PostgreSQL. You don't have to worry about the overall DBMS architecture. So we're never going to ask you, hey, what is the second layer of DBMS? What's this on the disk? You don't have to worry about that. And everything else is definitely examinable. But to what extent? Well, we'll discuss that at the end of the today's lecture. We'll talk about specifically what questions we'll ask and what will be tested heavily and what will be tested lightly. And in Monday lecture, we talked something about the databases and technologies beyond traditional relational database systems. So we talked about NoSQL databases. We talked briefly about vector databases and retrieval augmented generation. So this part, you don't have to worry too much about it. We're not going to have a question dedicated for it. In the question 8 of our exam, we have like a couple of multiple choice, so they could occur in this part. That's the only part they could occur. So we could ask you something like, what does NoSQL stand for? Or we could ask you something like, what is the advantage of vector database compared to traditional database, and what is the advantage of how is vector databases are used in retrieval augmented generation? So we're going to ask you very simple questions in these theory questions, and the majority of the exam will be about writing code. So this is the breakdown of your assessment. So quizzes, and I think many people know that I've granted a lot of extensions for the quizzes. So the point of quiz is to push you to study every week. So it's not a place where I want to take points of you. So I want people to see that as a motivation to study every week. So most likely, if you're late for a quiz, most likely we have some kind of arrangements to do that. And for assignment 1, you already know your score. In assignment 2, the majority of people will know their score in Saturday. And exam is pretty heavy. Exam, you got like 60% out of the total grade. So exam is pretty important in this course. And you know what is the passing score for the exam. And so that's the provisional results for assignment 2. Don't have to look too much into it because this is just the test we run like globally. Like we haven't written the feedbacks to you guys yet. So this is just to let you know that you guys did well. I think most of you guys learned how to program in PsychoPG2, and most of you guys solved the majority of the questions. That's very good. And the exam will be on May 8th. So there is a morning exam and there is an afternoon exam. And please make sure that you know which slot you're in. And there are a couple of groups for this exam. So I think we ran so if you got a real clash, which means that, for instance, you have an exam in the morning, another exam, like let's say a math exam in the morning, and then you could take the exam in the afternoon, then you should let us know, and you should let CSE exam know. We have probably sorted out for you already. And if you do have a real clash is like if you cannot take the morning exam and you cannot take the afternoon exam. In that case, you need to be moved to May 11th, where we'll have like another exam going on. So basically, yeah, do you have a question? Okay, you're just right. Okay. And in the exams, this is a proper CSE exam, so this is what I like about this course. A lot of other courses, they do online exams, and eventually you don't know how the students are actually learning, and they ended up writing everything using AI. So this is a fully invigilated exam environment. You'll be in a CSE lab, and you don't have access to web CMS, so you don't have access to any of these. You won't have access to email or web. You do have access to PostgreSQL manual, so technically you don't have to memorize anything, and we will provide documentation for you. And of course, you don't want to bring your laptop. And you have access to a web browser, obviously. That's how you can access the exam questions. And for each question, we'll also provide you with a template. So for some template, we don't give you any starting code. For some questions, we give you a code template where you can just get started easier. And you can use auto test to see whether you have passed the test. So if you pass the test in the exam, it means that on that specific question, on that specific database, your query worked, but it is possible we test on a larger, more complex database with the same schema. So if you pass the test, most likely you're okay. And you don't have access to your home directory, you don't have access to the class directory. Of course, otherwise you can prepare a lot of the stuff in advance. So pretty much you only have access to the browser and the PostgreSQL menu. So if this is your first CSE exam, I mean, if you have taken CSE exams before, then this should be a no-brainer for you. You just walk in there, and then you know the drill. But if this is your first CSE exam, you need to be careful about a couple of things. So you need to always bring a valid ID. So it cannot be, the student ID cannot be expired. So sometimes the expired student ID still works, but you need to make sure that the date is still, we haven't passed that date yet. Otherwise, expired ID equals no ID. So if you got no ID, then you got a whole bunch of process you have to go through. Don't do that. Just bring your student ID, and if you, or bring your New South Wales photo ID or a passport, anything like that. And if you are, and I think you're allowed to bring a water bottle, but a water bottle needs to be 100% transparent. So you cannot bring something like that. And even if it's like half transparent, not allowed to do that. Cannot wear a hat, cannot wear a hoodie. So those sort of things. And the files, each question has a dedicated directory, and we put the files in there, and then we also put a check script. So you can use the check script. You can also use the auto test. And for theory questions, we have a TXT file for you. You can type your answers in there. So if we ask you, hey, do these BCMNF questions for me, then you can just type your whole process and the end result in that TXT file. And always submit. So submit, do something, submit. And don't wait until the last moment to submit, because I've invigilated a lot of exams, and there are always students, for whatever reason, they don't submit until the last moment, and then they say this time is up, and then they're not allowed to submit anymore, and then they have to take a new exam. So, or they get a 0. So don't do that. Always submit. And even if you submit after when the bell rings, they'll just look at the timestamp, and then they'll just take the latest one before the deadline. So always submit as you complete them. You can submit multiple times. I think a lot of people don't know that, and that's why they freak out in the exam environment. So like previous offerings, we need to tell you in advance about the exam database schema. So the exam database is MyUnisW. So this is a centralized UNSW enrollment system. So this is basically very similar to what you have worked with in assignment 2. So I'm not going to bore you with the details, but you can look into it. So takeaway message is that kind of look like assignment 2. So don't have to worry too much about being exposed to a completely new schema. Okay, this is the schema. And now let's just have a review from the very beginning. And as we go, we'll talk about what we expect you to know and what type of question we are going to ask. Yeah?
First thing is
On Friday? Okay. Okay, I'll correct it. Thanks so much. And
Another thing is that based on current UNSW rules, you can only bring student ID and not ID for exam.
you need to check on that because I remember if you bring a passport,
No,
it's still a legitimate ID. So
I
um,
just
strongly, yeah, if you bring a student ID, that's best bet. And usually in CSE exams, they allow you to bring your passport. So if you got no student ID, no passport, then no exam. So um, new rule? Oh, great. Oh, great. So new rule, new rule. Thank you. So, okay, new rule, student ID only. Just bring your student ID and make sure it's not expired. So that's good. So I'll make an announcement about that, and thank you for bringing that up, because yeah. And let's go through the whole thing again, and in the meanwhile, we can talk about what type of questions we are expecting you to be able to answer. So at the beginning of the course, we talked about ER models. Everything can be modeled in entity relational model, and entities, relationship, attributes, and we got strong entities, weak entities. We got all kinds of relationships, and you're expected to know the weak entities, the multi-valued attribute, inheritance, derived attribute, and how they can be mapped into SQL. So we're expecting you to know how these relationships are represented in the ER notation. So this will not be obviously not be in the coding part of the exam, but in the theory part, we could ask you something like, hey, if you got a many-to-many relationship, how can we model that in an ER diagram, and how can we usually how many tables do we create for that schema? So that's the kind of things we can ask you, and you're expected to know how to write, how to convert that into SQL schema as well, and all of these details. And you need to know how to apply constraints on these on each attribute. And after that, we talked about SQL query and how to write views, functions, aggregates, as well as triggers. So things like this should be automatic to you at this point. In the exam, we'll create a database, we'll initialize an instance of PostgreSQL for you, and you'll be interacting with that database using PSQL. So just like you would in an assignment. So all of this, of course, is very important to you, because if at this point you don't know how to interact with the PostgreSQL shell, then probably you're in big trouble. And all these meta commands, I guess the most useful meta commands is \i, which allows you to run script, and \d, which allows you to list the tables or a specific table, and how to create the PostgreSQL shell. And after that, we talk about the SQL query language. So before that, we talk about data manipulation language. And what is more important to us that is going to be heavily tested is the SQL query language. So most of the queries follow a classic select from where block. And at this point, you should know a lot already. So select, we can select the columns from a table. From, we put the tables there, and where allows us to apply filtering conditions, and after that we can apply order by certain attributes. Let me see what else is. And you're expected to know how to filter rows based on a condition. You're expected to know how to write joins explicitly and implicitly, and you're expected to know how aggregate functions works. So you need to know how to use aggregates like min, max, average, and you need to know how to combine them with the group by clause. And you also need to, like we'll discuss later, you also expected to know how to define a user-defined aggregate. So basically, you can customize your aggregate. And you're expected to know how to do set operations. You need to do union, intersection, and differences on certain tuples, and you need to make sure that those tuples are union compatible, meaning that they have the same schema. So they need to have the same, exact same columns, and then you can actually do union, intersection, and difference. If they're different, inherently from different schema, then you cannot do those things. And group by filtering, so whenever you're doing a halving, you need to do it after a group by. So, and also whenever you do, when you group by certain attributes, that attribute is going to need to occur after the select clause. Otherwise, it will complain that you didn't select the attribute that you're grouping by. And so this is the classic select from where block. I think you should already know how to do that. And joins, you're free to use explicit joins or implicit joins. And I personally like implicit joins because it allows me to consider join as a filtered Cartesian product. So basically, if you write select from where, select something from a bunch of tables, it will give you the Cartesian product, basically all combination of tuples of those tables. And then if you add a where condition after that, it will impose the filtering condition, basically matching the columns after the Cartesian product. So I like to think about joins as filtered Cartesian product, and I like to write it as select from where and select from a bunch of tables, and then in condition, I put the joining condition over there. But if you prefer to write it in the explicit way, that's completely acceptable. So problem solving, you have solved enough problems by now. And in general, Vue provides you with a great tool to break complex questions into smaller steps. Just be aware of the cases where we ask you. So if in general, if you want to make a helper view, you can do that. But I think the same as in the question, as in the assignment, if we explicitly tell you, hey, cannot create a helper function for the function, then you cannot do that. So otherwise, you're more than welcome to create your own helper views to make it easier to solve a complex problem. So views are like virtual tables. So if you create a view, it doesn't really create an additional table. It just stores the query in the definition of the view in the database, and it will only be invoked at query time. So, but the beauty about views is that you can use it as if it is a table. So you can create something like that. You can define the attribute names, like the column names in that imaginary table, and then you can use it as if it's a real table. So they look like a table. They're very useful in simplifying complex queries, and you can name them differently. And if you want to create them repeatedly, it's better to create or replace view. Otherwise, they will complain, hey, we have created this view already. And two types of functions that are important in our course, PLPG function as well as SQL function. And you need to be familiar with both, and this is where we specify the type of language, the type of whether this is a PLPG function or whether this is a SQL function. And we'll definitely dedicate like one question in the exam for PLPG function or SQL function. So it allows us to have more flexibility when it comes to writing, when it comes to programming in with the database. So classic SQL is kind of like a declarative language, you're kind of bossy and you're telling the database what you want, what you expect from the database, and it doesn't have that procedural component of traditional programming languages, and that is why we talked about PLPG SQL. It allows us to combine the declarative programming in SQL and the procedural programming in C++ and Python, so that it's more flexible than classic SQL, and it allows us to declare variables, allows us to write control structures like if, for loop, if statements, for loop, while loops, and it allows us to return results. And it is a fundamental part of the trigger as well, so I guess functions are super important. And you can also execute dynamic queries, and you can handle exceptions, and it allows you to print something so that you can debug. And the record variable is very important in PLPG SQL because I'm not sure if you remember, if you want to represent a tuple in a table, I think there are 3 ways to do it. One way is you can use the record variable. It will automatically look at the table, and it will take after the shape of that table, and it will be able to store a tuple with the same columns. Or you can define it as tuple, some table name, and then percentage sign row type. If you define it as a row type, then it can only represent that specific row type. And if you declare it as if you define it as a record, then it is more flexible. So you can use it in this query. For instance, this could be a student table, then this will represent a tuple in student. And then in another for loop or something, you could be working with an enrollment table, and then that record will be storing 1 row in enrollment. So it's pretty useful and fairly flexible. And so functions, we can return 1 value, or we can return a set of values just like we return a table. And so functions are kind of just like parameterized views. So we can manipulate the input, and then we can get different outputs. And views are like, our views are just used like tables, and they're just storing 1 view of the database, basically storing a specific static query of the database, and they can be reused as well. And select into is very important in PLPG SQL functions. It allows you to store the value of a query result into a local variable. So this is a perfect example of combining procedural programming language with declarative programming language. So here you run a SQL query, and then you select that into a variable. So this variable needs to be defined beforehand, of course, and then and then that local variable will store that value for you. And then you can use that local variable for all kinds of crazy things. You can use that to match other tables. You can use that to match other tuples, obviously. And dynamic queries, probably not going to use that in an exam. It's still very useful, but it's not going to be super relevant in an exam environment. And iterations, well, the whole point of introducing procedural programming language so that we can have some sort of loops, or control structure. So the for loop and the while loop and the if statements are the building blocks of procedural programming language. And thank God we're allowed to do that in PLPG SQL, and otherwise we cannot really express complex logic. So you're expected to know how to go through each tuple in a query, and then apply if to check some conditions, and then go ahead and modify a table or return certain result. So most likely we're not going to ask you to modify a table. the majority of the exam will be focused on querying. So we'll ask you, so consider yourself like a data scientist, like we're asking you to extract insights from the database. Most likely we're not going to ask you to modify the database, because if you start to modify the database, it becomes a mess. And it's hard for evaluation purpose as well. And and when you find yourself, well, I guess this is a no-brainer. So if you find yourself writing a nested for loop to get something that you could have done in join, then always use join. So basically these are equivalent in terms of the tuples returned in the end, but obviously the second option will be a lot faster, because the second option allows you to take advantage of the SQL, the power of SQL query planner. So it will take a look at those tables, and it will figure out the best plan to join those tables, and then it will probably use an index, it will probably use sort to make this part very fast, and it will probably apply some filtering in practice as well. And then you just need to go through every tuple in that result. And in this case, you're kind of forced to iterate through every tuple from the first table and then every tuple from the second table. So you're basically cutting the query planner out of the picture, and you're forcing it to do a very high time complexity operation. Aggregates reduce a connectional value to a single value. So we have some inbuilt ones, the minimums, the maximums, the averages, and we could using it is very easy. You can use it in query, or you can use it with the group by clause to get the average in different groups, to get a max and min in different groups. And what's more interesting is that we could probably ask you to create an aggregate that we have defined. So we could ask you, hey, we got a bunch of numbers and I want to compute the variance of these numbers. So variance, so we got to take the L2 loss divided by the number of samples. Or we could ask you to compute harmonic mean, median, things like that. I think a median is a very difficult problem. And so basically, we could ask you to come up with a user-defined aggregate that works just like the built-in ones, but with different expected outcome. So one of the reasons is we have, I think in class we demonstrated how to recreate the count and how to, I'm not sure if we have demonstrated this, but this is also an easy example. So we could ask you to get the product of the integers in this group. So you need to be aware when we ask you to create a user-defined aggregate, you need to be aware of these four things. So the state of the type of the state, the initial value, the state transitioning function, or some people call it update state function. So somebody else call it state transitioning function, and the final function. So you need to understand the data flow underneath to really be able to come up with a user-defined aggregate. So so in count numbers, so if you're counting, so basically the initial condition is 0, and then the state transitioning function is that we just add 1 to the count. That's how we transition the state. And the final condition is nothing. We don't do anything with the final result. And the final function allows you to apply the final touch to your intermediate result. And if you don't need a final function, that's fine. But if we ask you something slightly complex, then you could benefit from having a final function. And in the product, it's the same thing. The initial condition will be 1, and then the state transitioning function will be, just grabbing the current value times the next value. And it doesn't have a final function either, because is not needed. So we're just multiplying integers. So that's an easy case. Something cat, we could also implement that. So these are the easy case because they have a single value state. So everything just accumulates, and we just store one state in there, and we don't need a final function when because the initial state in the end is the answer. And slightly more complex is we could ask you to create a user aggregate that need you to store two states in the state transition function. So for instance, if I want to create a range function that returns the maximum minus minimum over a set of values, then for every tuple we see, we need to record the current maximum that we have seen and the current minimum we have seen. So in this case, we need to store, we have like two balls to juggle, and after we go through all of them, we just take the max and min, and then the final function will just be max minus min. So we could be asking you something like that, and it requires you to properly define the initial condition, properly define the state transitioning function, and properly define the final function. So it's not that hard though. You just in this case, it's not that hard. In each state, you just keep track of the current max and the current min, and then the final function you just just do max minus min. And yeah, so we could ask you to write a user-defined aggregate, and triggers are also super important. It allows us to enforce a lot of rules that we couldn't enforce via basic data manipulation language or basic data definition language. Meaning that we have talked about a lot of constraints for the schema. We could say, hey, this is a primary key, this is not null, this is this and that. But a lot of the constraints cannot be enforced by data manipulation language, by data definition language. And that's what triggers are used. We need to use triggers to maintain summary data, to track schema level constraints. For instance, we need to make sure that total number of students does not exceed 700 people in COMP3311. And that's not something that the table levels constraints can do. And that's where we'll need to use schema. And also, it allows us to perform multi-table updates. So if you've got like a new enrollment, then we should probably update that in another table. And then if somebody drop out, if somebody withdraw before the census date, then trigger is used to update that as well. So it allows us to provide event condition action program, and it's triggered by three events: insert, delete, or update. And it can be triggered before the event or after the event. And in general, it can be fired for each row, affected row, or it can be fired for each statement. And most likely, in our course, we're focused on the ones that are fired for each row. So statement-wise triggers, we're probably not going to ask you to do that because we didn't provide enough examples for that. And I think we provided I think we have one additional prac work that I recommend you to look at. Updates and triggers. I think we remade this so that now it reflects all combinations of the triggers that we are interested. So there are 3 events, and we could fire a trigger before each of them, and we can fire a trigger after each of them. And then each of these combination, we need to think about whether we can properly define the old variable and the new variable. So old variable stores the old copy of the data, new variable stores the new copy of the data. And And if you really consider for each statement and for each row, it becomes 12 triggers, but you don't have to worry about the statement-wise triggers. So for each of these, we're talking about for each row. So in here, you can see the syntax. We're talking about for each row here. For each row, we're firing that trigger, and then when that event is triggered, we will execute a function. So we'll have one question dedicated to triggers as well. And CyclePG2 is something you have just practiced. I feel like you should be pretty familiar with it based on the provisional results. So basically, a Python library allows you to interact with the database. And if you go to the workplace, they'll probably have something else. They could be using CyclePG2, but they could be using something else. But the main idea is the same. It allows you to program in Python, and in the same way, you need to be careful of the amount of data is transferred from the database to your application. So we want to minimize that data transfer, because that's like a dominating source of latency in practice. And you obviously need to know all of this syntax, how to connect to a database, how to initialize a cursor based on a connection, how to execute a SQL statement, and how to preview the SQL query you're going to execute before you execute it. So that's called mongrify. And how to do fetch all, how to do fetch one. So pretty confident you guys have know how to do that already. So okay. And I think we have like one question about CyclePG2, and we'll talk more about the mark distribution in the end. And in the second half of the course, we started to talk about 4 important topics. We talked about relational design theory. So what makes a schema good or bad, and how do we define something is good or bad? So basically, the motivation is that with the existing data definition language, even with triggers, we cannot get rid of a lot of redundancies introduced by functional dependency. So basically, we got a bunch of columns that are correlated, and it gives us a lot of redundancy in the data. And the whole relational design theory is to reduce or eliminate the update, delete, and insert anomalies created by functional dependency. So functional dependencies, you need to understand the basic theory and definition. You need to know the basics of normalization. So we talked about a lot of normal forms actually. We talked about first normal form, second normal form, third normal form, and then Boyce-Codd normal form. And for first and second normal forms, we don't expect too much from you. As long as you know that as long as you know that to satisfy second normal form, you need to be first in first normal form. To satisfy third normal form, you must first be in second normal form. So we don't expect you to do second normal form decomposition, obviously. The only decomposition algorithms that we expect you to know are third normal form decomposition as well as Boyce-Codd normal form decomposition, because they have these algorithms that you can basically follow and get the results. And so in the third normal form, in the third normal form, first of all, you need to create a minimal cover, and then for each functional dependency in the minimal cover, create a new relation. In the end, if the candidate key is still not in there, throw in the candidate key. And for Boyce-Codd normal form, for each functional dependency, you need to check whether the left-hand side is a super key of the whole schema. If it's not, then you need to create a new schema for it. and then you need to get rid of the right-hand side of that violating functional dependency in the original schema, and then you need to repeat that process until every little relation is in BCNF. And something we expected to know is that the third normal form, if you follow this decomposition algorithm, you can expect your result to be lossless join as well as dependency preserving. So lossless join meaning that the decomposed relations, if you join them back using foreign keys, it will be the same as the original table. Dependency preserving means that every functional dependency in the original set is still preserved in a decomposed relation. And in BCNF, lossless join is still preserved. However, dependency preserving is not always guaranteed. So we could ask you something like, hey, do the BCNF decomposition for us, and then we will ask you, hey, is this lossless join? You will say, yeah, it is because it's guaranteed. And then I will ask you, we'll probably ask you, is this dependency preserving? You will say, not sure, we need to check. So, so this part of the content will only be in the, I think we have one question for relational design theory. And in the and note that for BCNF and 3NF decompositions, it is possible you get like more than, it is possible they have more than one correct answer for it. And in the exam, we'll try to make it as obvious as possible so that following our algorithm, you get what we get. And in the unlikely event that you're getting something that we're not getting, so you're providing a completely different decomposition that follows these steps, but it has a different result from us. If it is still 3NF or BCNF, we'll take it. Because we understand there could be more than one way to do it, depending on, for instance, in BCNF, depending on which functional dependency you pick out first, you could end up with slightly different decomposition. Okay. Do you guys want to take a break for 10 minutes, or do you think we should just go on and go to dinner earlier? Show of hands. Pardon? Okay, take the break then. We'll come back in 10 minutes and we'll talk more about the other type of questions. All right. Let's come back to our discussion. So thank you so much, thank you so much. I've just checked that you're right. So I need to stress this again. So the policy now, as of 2026 term 1, the new policy is that no student ID, no exam. Let me see. I think I've. So no student ID, no student card, no exam. Other form of identification will not be accepted. So please bring your student ID. Thank you for bringing that up. So I'll make an announcement before the exam, so that you'll be reminded. Okay, and so this is kind of a question we could ask you in the exam, and we're expecting you to type that into a text file. So we're giving you a relation, we give you a bunch of functional dependencies, and we'll ask you to decompose it into B, C, and F, or we will ask you to decompose it into the third normal form, and we could ask you to compute the candidate keys, and we could ask you to compute a closure, and we could ask you whether decomposition results is dependency preserving. So if we do ask you to do the third normal form decomposition, then if we ask you is dependency preserving, lossless join, yes to both. If it's like BCNF, then lossless join is yes, and then dependency preserving, you need to check in each decomposed relation. In each decomposed relation, for each of the original functional dependencies, if it is preserved in one of these sub-relations, decomposed relations, then you can say, hey, I checked the decomposition is dependency preserving. So let me see. So you need to show us work, obviously. You don't want to just type your result in there. You want to show us your chain of thought. So why do we pick this? Why do we pick on this functional dependency? And we need to see a working example. Basically, we want to know how you arrived at your conclusion. And the advantage of doing that is that even if you mess up in the end, we can still give you some points for showing us the steps. So, but if you give us the final answer, and it's wrong, and there's no way we can possibly grant you any points for intermediate steps. So, please be sure to include intermediate steps. So for computing candidate keys, we could be asking you to compute candidate keys. Easier way is we could be asking you to check whether something is a candidate key. So listing all candidate key, slightly harder. Checking whether something is a candidate key, much easier. So in this case, we just start with everything on the left-hand side, and then we just iteratively take out the attribute and see if the closure of that attribute set is still all attribute. If the closure of a set of attribute is all attribute, then it means it is a super key. And if you take any of the latter, if you take any of the attribute out from the set and it stops being a super key, then that's a candidate key because it is the minimal candidate key. And please be careful. Like when we talk about minimal super keys, we're talking about minimal, not minimum, which means that there could be a bunch of candidate keys out there. They could be overlapping, they could be non-overlapping, but the point is they're not. It's not possible that one is dominating the other. And the same thing with minimal cover. So if we follow those 3 steps, you could get a slightly different minimal cover from other people's minimal cover, but it is possible both of them are legitimate minimal covers, and that's why they're called minimal cover, not minimum cover. So just don't freak out when you after the exam you talk to your mate and you got a different minimal cover from your mate. Then it is possible both of you are right. And so the keys and the BCNF decomposition is pretty straightforward. You just need to follow the algorithm. So to begin with, you need to pick on each of the functional dependency, and you need to see whether the left-hand side is a super key. Well, to check that, compute a closure. The closure is not all attribute, then there's a violation. So because all of these are violations, so you need to pick one of them. So if you just pick C determines A, that's a violation, then you can start the split from AC and BCDE, or you can pick on D determines E first, and then that could make you end up with a slightly different BCNF decomposition. And most likely we'll give you a fairly easy example where you won't have, it won't be a huge difference which functional dependency you pick on first. So that makes it easy for you, and probably make it easier for me for marking as well. Well, dependency preserving check. So if it's already third normal form, you don't need to check that. If it's Boyce Codd normal form, you did need to check that. Just check for every functional dependency in each subrelation and see if it's preserved. And sometimes you need to think about all of the implied functional dependency as well. So I guess if you follow the examples that we've been providing, you should be in good hands. And relational algebra, I don't think we have a dedicated question for it. And query evaluation, we don't have a dedicated question for it. So all of these, if we do test them, they could be in one of the multiple choice. So we could be asking you, this is a SQL statement, which of these relational algebra match the SQL statement we gave you? Then you just need to select the one that is consistent with our SQL query. And for query evaluation, you don't have to memorize all these components. You just need to understand that the query planner parses your query into relational algebra expression, and then it will look at different query execution plans, and it will try to find the best one. It will not bother to find exactly the best one. It will spend some time find approximately the best one based on the statistics it knows from the database, and then it will execute that approximately best query plan for you. And how do we get a query plan? We use explain in front of select statement. So we could ask you, hey, this is a query, identify the weak point of that query. Usually it's a sequential scan. Then what can we do about it? Most likely we can create an index on that. So in a multiple choice, something like that. So we're not going to ask you to do, we're not going to ask you in the other questions. So this part we'll ask you in the multiple choice. And database performance, don't have to worry too much about that, because we don't really have time to test your knowledge on how to really tune the database to make the application perform better. It's just useful to know in the long term. So you just it's kind of like a knowledge you should have when you're solving all the other problems. Like you need to have this knowledge so that you know why your query is slow. And we will not like allocate a question to just test that. Like we're basically testing that when we're giving you the view questions as well as the function questions and trigger questions and stuff like that. And after relational algebra, we talked about concurrency control, multi-version concurrency control, and the one thing that we're specifically interested in exam is serializability check, because this is where most of the examples are from. Multi-version concurrency control is very useful in practice. And if we do test it, we'll test it in the multiple choice. We will not ask you, hey, user 1 typed this, user 2 typed this. What do they see in their interface? We're not going to test your deep understanding of MVCC. We will test you how to do serializability test. So the point of serializability is to find a concurrent schedule that is equivalent to a serial schedule. So if you got a bunch of transactions, there are n factorial possible serial schedules, and if we do things serially, then correctness is guaranteed. However, it is very slow. So in computer science, we always want to run things in parallel so that we can speed up the process. Just like, right now they use CPU, and then after that they run things more in parallel. They have like 1,000 threads. They invented GPU that allows us to do crazy AI models and stuff like that. So the gist is we always want to run things in parallel, concurrently, and that's why we need serializability. And it'd be very useful if you can kind of memorize the Venn diagram that I give you in the beginning of the serializability lecture. So we have all schedules, and within all schedules, we have all serializable schedules. So it'd be nice if we can know exactly whether a schedule is a serializable schedule or not. But reality is that is very hard. So we settle with conservative tests, and within that, less conservative test is view serializability, and more conservative test is this conflict serializability. And conflict serializability is the strictest. It is the strictest form of serializability, and within that is just the serial schedules. So we could ask you something like, if something is already, we have proven it to be conflict serializable, then you should know that it is already view serializable, and the flip is not guaranteed. So if you check something is already view serializable, we ask you whether it is conflict serializable, you'll say no. I need to check. So we need most likely, if we have a question dedicated for serializability. So we have that. I think it's the last question. And what we'll do is that we'll give you a schedule, and we'll ask you to check whether this is conflict serializable or whether this is view serializable, and you need to show us the steps. So things like this will also be completed in a text file. So obviously, we're not going to give you a scratch paper that you can turn in. I think you can be granted a scratch paper in the exam, but we'll not look at your scratch paper. So we'll not expect you to draw a nice precedence graph, and most likely will not ask you to work on schedules with more than 3 transactions. So most likely we'll ask you to do something with 2 transactions, or at most 3 transactions. 4 transactions is crazy. I don't even want to do that, because 4 factorial is like 24. So if we got like a 2 transaction schedule or a 3 transaction schedule, you need to show me whether there is a cycle in the presence graph. So in this case, you need to look at the conflicting operations, and you need to tell me the edge in the presence graph, and then you need to show me there is a cycle in the presence graph. So you don't have to draw that, but you need to show me T1, T2, T1, that's a cycle. So if it's a cycle in the presence graph, it means it's not conflict serializable. And if we ask you to check view serializability, in that case, if we ask you to check view serializability, which we will do that. You need to check it for every possible serial schedule that are related to these transactions. So if we got 2 transactions, T1, T2, what we want to do is that we want to check 2 possible serial schedules, T1 first and then T2, or T2 first and then T1. So we need to check both of them. If the original schedule is not view equivalent to any of the serial schedule, then it is not view serializable. So if it is equivalent to at least one of them, so if it's, for instance, if this is equivalent to 1, if this is equivalent to T1, T2, then we say this is view serializable. And in each case, so you see that we need to do this for each serial schedule. So if it's if there's 2 transactions, we need to do it for 2 schedules. If it's like 3 transactions, you need to do it for 6 schedules. Basically, all of the ordering of T1 and T2 and T3. So T1, T2, T3, T1, T3, T2, T2, T1, T3, T2, T3, T1, blah, blah, blah. 6 of them. For each of them, you need to check, you need to perform those 3 tasks. So the initial read, and the dependent read, which is read from, and then the final write. So basically you kind of need to check by definition. You need to check whether your schedule. So let's just say that I need to check this schedule 1, as well as this serial schedule T1, T2. For those 2 schedules, I want to check whether the same transaction performed the same initial read on each data item. In this case, there's only 1 data item. That's fine. We just check A. And then if there's a dependent read, in this case, there is no dependent read because we're always reading before writing. So if there's a dependent read, we need to make sure that the same transaction wrote on that data item, and after that, the same transaction is reading from that. So basically, it's kind of like Tom wrote something on A, and then Jerry is reading from that. And then that same relationship should be carried over to another schedule to make them view equivalent. Because Jerry is always reading a copy from A that Tom just wrote. And also we need to enforce the final write. So the same transaction need to perform the final write on that data item. Well, when we only have 1 data item, we just do this for A. And if we have multiple data items, like we have X, Y, or Z, then you need to do these 3 tasks for all data items. So because this is defined on 1 data item X. So basically, for each serial schedule and for each data item, you need to check these things. And if any of them are equivalent, then it's view serializable. So this is a slightly harder problem. This is like 3 transactions, and if we do ask you to check view serializability, you need to check all possible serial schedules with the given schedule, and you need to compare whether they are view equivalent. Okay, that's enough with this, and this is also on the easier side because we only have like 1 data item, and I can promise you we won't have it more than 2 data items. That's just going to be too much work and too much repetitive work, which I don't believe is needed. So in the same thing, you need to show your chain of thought. You need to show your steps, show your intermediate results, so that we can see how you arrive at a conclusion. And if you didn't get it right in the end, we can still grant you some points based on your previous work. And we have some multiple choice questions that look like these. So we're gonna do. So these are some sample multiple choice questions, and we could ask you about relational theory, transactions, as well as modern database technology. And for instance, this is a list of functional dependencies. What is the candidate key? This is the easy one, just compute a closure. And the second one, this is a bank transfer example. And which property of ACID does it reflect? So it says that it crashes after the server crashes, and after recovery, it is still fine. So this is basically testing your knowledge on basic ACID properties. So isolation, atomicity as durability, and here this is durability because durability is testing whether the database can survive crashes. And the last one, we could ask you a little bit about NoSQL databases as well as vector database. One thing we expect you to kind of know about NoSQL database is that, first of all, NoSQL stands for not only SQL, not SQL. So if we ask you what is NoSQL and you said not SQL, not NoSQL, then that's wrong. And also we expect you to know the 4 families of NoSQL databases, like the white column family, the graph family, the key value family, and we need to know, and that's about it. So we expect you to know NoSQL stands for not only SQL, as well as the 4 NoSQL families. And for the vector database part that we discussed on Monday, the second lecture of Monday, we expect you to know that vector database depends on similarity search, and it is great at capturing semantics instead of exact matches, and it is the building block of it is the building block of retrieval augmented generation. So a RAG. So RAG is super popular now. That's why I want people to understand that knowledge, and the vector database is responsible for retrieval part of RAG, and obviously large language models like ChatGPT, things like that, are responsible for generation part of RAG. So vector database is responsible for retrieval, large language model responsible for generation. I mean, I think people can get it right even if they don't know, even if they don't understand that very well. So here, this could be a question that we're asking. So what is best to suit a traditional RDBMS rather than a vector database? Well, every traditional database functionalities like exact matches, range queries, we want to do anything that you can think about solving. You can solve using a SQL query. Is probably suitable for traditional RDBMS. Like in the first one, recommend songs similar to a mode. Well, when you look at the mode, you need to look at the semantics of this listening history. You need to do semantic matching. And for the third one, images similar to that, that's not available in traditional database. And the last one is also what we want to find articles related to a sentence, and we don't want to do exact match, then that's something that the vector database can do that traditional database cannot do. And the second one is something that the traditional database is good at. So basically, we retrieve all orders placed by a specific person in the last 30 days. So this is kind of like a classic SQL use case where you can solve this in one line. Select all customer ID, select all orders where customer ID is 42, and then where timestamp is blah blah blah. So traditional databases are great for these queries and exact match. So anything that requires semantic, vector database is better. And that is why we use vector database for RAG. Okay, and it's enough with the revision. So this is the actual exam structure. So we have like nine questions. So these 6 questions are practical questions. So we got a SQL view question, another SQL view question, and we have a Python question. Obviously, you will need to write in CyclePG2, and it will be you interact with the database, of course. We're not going to ask you to write Python to implement something else. And you have a function question, could be PLPG function, could be SQL function. And we have a trigger question where you need to implement the trigger, also implement the function called by the trigger, and you need to implement a user-defined aggregate. So I think we talked enough about user-defined aggregates in this in the revision lecture. So that's some, we have one question about that. And for the theory part, normalization deserves one question. So BCNF or 3NF. If we do ask you about first normal form and second normal form, it will be in multiple choice. So you don't have to stress too much about first normal form and second normal form, and they're only going to occur in the multiple choice. And the last question is about concurrency control and serializability. Most likely, it will mimic the previous serializability questions in the past exams that we handed out. Like, I think one of the exams have a serializability question. It will be kind of like that. So, and for all the other stuff that don't fit in these things, they are in question 8. So question 8, we got a few multiple choice. We could be asking, hey, what does NoSQL stand for? Hey, is this ER diagram look okay? Then all of that stuff, it will be in question 8. And revision material, I strongly recommend you just look. I think just the web CMS materials are good enough. I think we have provided, like, we are the first course offering that to make videos for the practical exercises. So so previously we didn't have these videos, so we made videos for them. And the practical work are great material for revision, tutorials as well. But just, I mean, if you look at tutorials, I guess if it talks about SQLite or something like that, you can just ignore it. We're not going to test SQLite, but all the other stuff that is relevant to things here, you should understand them fairly well. And supplementary exams only available for people who are absent from the final exam for a good reason. So you cannot say, I don't want to do that. I have a dinner date with my girlfriend. I need to attend the wedding. It needs to be, usually it needs to be pretty serious, and you cannot control it. You need to show them that you're kind of sick and then something happened to you. You cannot attend our normal final exams. Then, and also, it's granted to people who have performed well during the whole semester. We look at your track record, and we'll grant you a supplementary exam. And if you do take a supplementary exam, it will usually be held in the all week of the next term. So the supplementary exam structure will be about the same, but it will not be the same exam, obviously. And if you don't attend that, we're just going to give you 0, and we have no choice, because we cannot keep arranging new supplementary exams into the future. And so I think UNSW, correct me if I'm wrong, I think UNSW has a no, if you are well to sit the final exam, you cannot ask to take the supplementary exams anymore. So if you're not well enough, just don't show up in the final exam. If you show up, then you have to take the final exam, and we will not grant you a supplementary exam. So I think it's called a fit to sit policy. So if you sit the final exam, we cannot grant you that. And assessment is just a test. So the important thing, obviously, is to learn these skills so that it can be used in whatever you want to do later in life. If you want to do research, if you want to work in a company. So skills is the most important part. And don't. It's just a math assessment. It's just an exam. Don't let one exam ruin your life. If you didn't do well in the exam, it's not the end of the world. And the point is, you understand something and you learn something that you can use. So I think, and I'm doing research in database and large language models, and working with some brilliant minds in UNSW. And so if you think database is interesting, and can contact me. We can discuss what we can do together. And also, this is a two-way street, and we'll assess you, and you get to assess us as well. So my experience evaluations are still online. So if you got anything, any feedbacks on our course, feel free to take the survey. I think the survey ends next Friday or something. And beyond this course, there are a couple of related courses. I personally think if you're interested in more about NoSQL databases, then 9313 is a very good course. It teaches you the classic MapReduce, Spark, things like that. If you're interested in what is happening under the hood of the relational databases, then you could take 9315. So basically, they use C language to implement all those relational algebra operators. You understand how indexes work, how disjoins works, and if you want to explore more about graph databases. So this is my specialization. I help design that course. You can take 9312. The beauty about that course is that it is not only a course about graph database, it is also kind of a very code-heavy and a data structure and algorithm-heavy course, which I personally think it prepares you, it very much prepares you for a code interview in real life. I'm not sure if they still do code interviews given the changes in the workplace. So it's a great, it prepares you for database, data structure and algorithm part of the coding interview. It forces you to think about a lot of, implement a lot of algorithms from scratch, and I think overall is a very, very well put together course. So yeah, that's enough for today. And one thing, so I really appreciate you guys, especially the people who attend my lecture every day. So thank you for giving me a stage, and if there's anything I can help you with, if you run into a problem, if you need a recommendation letter, please shoot me an email. I'll try my best to help students. And also, we have a couple, I think we have like 2 weeks until the exam. So I think videos and things like that are great study material. So if there's something that you think, I didn't understand well, something that you think I need better demonstration, I think you should email our course email, or post on the forum, and we'll see what we can do, and we'll make the best use of the tutor's workload so that we can we can better support you, better prepare you for the final exam. Okay, and that's it. Thank you so much for the time. Thank you.
I think for me, like the methods I use is just for A, the initial is
T1.
T1.
Yeah, T1.
But why do you mention at T2?
You need to check.
So answer is just T1.
Yeah, it's just T1. It's just T1. you don't have to worry about that. So you need to check whether it matches with, so you don't have to worry about in T2 because so
not
ba-
initial.
yeah, so basically it means, so basically T1 is the transaction that
First
raise
value
the value of A initially,
Yes.
and then you need to check whether the same thing happens in one of these. So in here, if it's T1 and then T2, then it matches. T1 met. So if it's T2 and then T1, then in that case, T2 have the initial rate. So basically, so this is it matches this.
So if we find that for this schedule, is it already real equivalent? Do I still need to check the second one?
Oh, if it's already no, don't you don't need it. So just if one of them is real equivalent to your original schedule, it means that your original schedule is real equivalent to some serial schedule, which means that
Already
yeah.
severizable.
yeah, like one of them is good enough.
So like you mentioned, like if we have 3 transactions and have 6 possible, but if we only find one, and it's all good. We don't
Yeah.
need to check every 6 possible.
Yeah, if it's like 6 of them, and then you happen to check the one that
Yeah.
is equivalent, and then you can say job done. The other 5, no, you don't have to do that. The other ones you don't have to check them anymore. So at least as long as at least one of them is equivalent to your view equivalent to your original schedule, then is view serializable. I feel like I should make a video about this. What do you think?
About how to check it.
I feel like you understood the details because I talked to you last time, but I'm not sure if because yeah.
So also I have confused here. So in this case, T1 and T2 also be the initial rate of A, right? They both initial rate of A.
Initial read, you just need to look at what is the transaction that reads it first. So initial read is just T1.
But in this case, you get a tick here. T2 read initial A and get a key.
Yeah, that's because in this is serial schedule. So in this T2, T1, this is another schedule. So
this is not match. Not matched for the original schedule.
yeah, that's not a match.
So
it's
it
not
should
a,
not have a tick.
yeah,
here.
should not have a tick. So I meant check. So yeah,
Alright.
I'll update that. Yeah.
So thank you.
Thank you so much.
Say thank you for this term because
Okay.
I really enjoy this course and your notes are really like it's very detailed and help me learn a lot.
Okay, thank you
I just
so
want
much.
to say thank you.
Okay, thank you. Thank you so much.
Bye.
Pardon?
When is the final exam?
Oh, when is final exam?
Yeah.
I feel like you should have already received an email.
I don't think I received
You didn't receive an email?
Yeah.
For most people, it's May 8th.
Yeah, I know it's on like Friday, but like, what's the time?
I think there's a specific. Let me show you. There is a place where you can check your exam allocation.
Like on CV.
Yeah, I think they have a system where you can check your exam. You know what? I will make a notice about it. Yeah.
Okay.
I'll make a notice about it and to give you a walkthrough, like how you can find that. Okay, thank you.
Where can I get email? I can get an email.
Like my email or my course email?
No, not possible. Like your email.
I think my email is listed here too.
In lecture slides.
Right. I should have my email. Because I get people email me all the time.
Okay.
You can just email that for the time being. Or what do you want me to email you about?
Like about recommendation letters or something.
Oh, okay. So just write my my first name
Okay.
dot last name
Okay.
at unsw.edu.a.
unsw.edu.
Yeah. So just that part and then first name dot last name.
Oh, okay.
Okay.
Can I write it down?
Yeah. Yeah, just write it down and then me. Write it down and then me.
Can you type it down for me?
Yeah, I'll just type it. Yeah, that's that. So last name dot first name dot last name at unsw.edu. Yeah.
Okay.
You kind of a job or something?
No, for the master.
Okay.
Yeah, yeah. So
Are you planning to do a coursework master or a research master?
I'm not quite sure. 'Cause
Okay.
I don't even know which country to go.
Okay. Yeah, just let me know in the email.
Oh, okay. So other question is, do you have a starter file for the Python program, or do you have to write the whole Python program ourselves?
Most likely we have a starter pack, I think.
Like it's only like some import or main function.
I think most likely we have that. Can you post that on forum?
Okay.
Yeah, yeah.
Thank you very much.
Okay, thank you.
Use library for like packing in the exam.
What kind of libraries?
Just
You mean pandas? Like
Python library.
anything you can use in the assignment 2, I think you should be able to use that because it has the same environment. They have the same environment, the VLab environment. So if you can use pandas in assignment 2, then most likely you can use that too. And PsychoPG2, of course.
I also have a question like on career. You said like that there's like application on like the database. Which jobs actually have the database application?
Database. So nowadays in 2026, there's to be honest, there's no one job that fits in database. Like everyone, I've actually talked to a bunch of people in industry. So right now, what they want is like they want people who can do it all. So you definitely need database expertise. You need to know how these things work, and then you probably need to know. So what kind of job you want to do? Like I'm talking about software engineering and traditional dev jobs. So what are you trying to do?
It's more like on business applications.
Business applications, business analytics, right?
Yeah.
Business analytics. The whole thing. That's a job title, like business analyst or data analyst. That's a job title. And then if you know how to use database, it's going to be a super plus.
So like if I specialize in database, so data analytics or like business analytics would be fine. Like would they be searching for that, or would they be searching for like a person from that background, like who graduated from business analytics degree?
So what degree are you doing?
I'm doing comp science.
Comp science, okay. But you want to get into business analytics. You'll be fine. I mean, the business people have to worry about that because you have the we're CS. If you've done CS and then you have a CS degree, and then you have working knowledge of software, and then you take 3311, you're more than qualified to do that because I always believe it's easier to teach software engineers business than to teach business people coding. So you have the coding background and is very, and then their set of interviews will be completely different, like from software engineering, of course.
For like software engineering, you said like database is like one of the things that you're looking for. Like, is it better to like generalize, or like is it better to like specialize?
Specialize. So my suggestion is, if you want to specialize in something, you got to be a real expert in that. And my suggestion to people in general, you probably need to know all skills. Like right now, what they're doing is that before they had like a back end. So before, like in probably 5 years ago, there was like a job called back end engineer, a backend developer or something like that, and then this course is like specific design, prepare you for that job, and then you deploy these things in the cloud, and then you're just responsible for insert, update, delete, stuff like that, and front end people handle buttons and stuff, and then that will hook up with your API. But now they need you to do everything. Like you need to know backend, and you also need to do React, like front end, and all of these can be done by a coding agent or something like that. But the thing with coding agent is that you need to have a good taste to make it work well. So if you work with databases a lot, and then you know what is a good query, what is not. But if you haven't learned any of this, then you cannot prompt it correctly. So now they're looking for somebody who can do it all.
Do it all. Because
Yeah.
there's AI, so like they're looking for someone.
Yeah, like in Australia, you mean?
Yeah.
In Australia, I feel like recently the AI engineer job is, or at least whatever you do, you can automate it. You can show people you can automate it, and you have the ability to use AI to scale up your work. That's super important, more than before now. But if you want to get into like the tech giants like Google, then LeetCode. Yeah, then they don't.
Oh, I thought LeetCode wasn't really, because I heard like someone use like a program to, I know like they use like cheat code, I mean like LeetCode, and then like they do the answers, but like they're still using LeetCode, or do you think like it won't change?
Yeah, but you say they're cheating. But in Google, they're asking you to write code on Google Doc or something like that. So you have to write something on the blank ID, not even a ID, just a text file, and then it needs to work, it needs to pass this and that, and also you need to articulate your thought process. So I feel like it's a lot harder to cheat. Yeah, like for tech giants, you still need to grind LeetCode, and for medium-sized companies, I think AI is very important.
I think Nico just work on interview, like only use it anywhere.
Yeah, in the interviews.
And maybe not use it Google, do you think?
Not so much.
Like algorithm, like I do 3121, the complex algorithm, like DP, device Congress, Redis. I don't think that's thing we really use on job.
Yeah, unless you're working on a very sophisticated piece of software, in which case they have to commercialize that, and then they just call it in the package or something. But yeah, it happens in everywhere, like in China, in Australia. The interview is very hard, and then when you get to the job, it's like you don't use dynamic programming. Of course, nobody uses dynamic programming, but they ask you that anyways to see if you're smart.
What kind of auto test do we provide at this time?
What type of auto
Like
test?
how can we check our code? Use what commands?
Like how have you been check your code in assignments?
Like some exam, like we just type auto text something, and it will check the question.
Yeah. We follow the same exam. Like basically, we're doing the same exam like before, but we have the different questions. That's the different thing. So if you look at past exam, if you can do auto test Q1, you can do something like that. We use the same auto test system.
Because I check one of the exams using the check shell script.
So one of the exam, which one?
Just the first one.
Okay.
We use the shell.
I can't show you because I have like a different view of. Let me see, exam 2023 term 3.
Yes.
I think that's the one we gave you.
Yeah.
Okay. Let me see. Question 4. And you can submit that, and then you can test that.
Yes. My question is just how to test that.
Well, I honestly don't know. I can take a look, but I shouldn't talk too much about exam anyways. But I mean, you don't have to worry about that because we'll give you the command in the HTML.
So do we need to, like, during exam, do we need to assign to the VSDB02 by ourselves?
Pardon?
Do we need to get into the
PostgreSQL?
Yeah, no, like when we're doing assignments, we use SH VSDB02, right?
Uh-huh.
Do we need to do that at exam?
I don't think you need to do that because I think in the exam environment, they have already done that for you, and then they have already created an instance of the database for you. So I think you should just do PSQL and that should work. Let's see.
One more question is, like, will we provide an ER diagram for our database, just like past exam?
ER diagram?
Because in assignment 2 we didn't provide it, and I need to draw that by myself.
Okay.
But I'm not quite sure if we will provide it past exam.
So you want an ER diagram for
It's
it?
more clear. Sure.
Okay. But the thing is, I don't think we have that because MyMyUSW is a huge database, and
There are a lot of tables.
yes, like too many tables. So, I mean, you have that database already. So from now to then, you can kind of.
Familiar.
So yeah, that's every term we release the shape of the database beforehand so that you can know. So we're not gonna throw you off with a completely different, unfamiliar schema. Yeah.
And one last question is, like, if we check some relation is BCNF,
Mm-hmm.
is it guaranteed to be a free NF?
Yeah. So 3NF is in here, and then BCNF is stricter.
It's true.
If something is in BCNF, it's definitely in 3NF.
That's all. Thank
Yeah.
you.
Thank you so much.
I enjoy this class.
Thank you.
I actually like to ask you about jobs. Let's say like the market. Your email just now.
Oh, so you want to email me about things like yeah, sure. Can we email the first course email then?
Oh.
I'll just reply you.
Oh, okay.
Yeah, I'll just reply you with my email.
Oh, okay.
Yeah.
Thank you.
Thank you. So if you just